Math 3 Lesson Summary Video. Any way you slice it. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to surface strategies for identifying the two-dimensional cross-section when a three-dimensional shape is crossed by a plane. Students in Mrs. Denton's class were given cubes made of clay and asked to slice off a corner of the cube with a piece of dental floss. Jamal sliced his cube this way. Jabari sliced his cube like this. Which student, Jamal or Jabari, interpreted Miss Denton's instructions correctly? Why do you say so? When describing three-dimensional objects, such as cubes, prisms, or pyramids, we use precise language, such as vertex, edge, or face, to refer to the parts of the object in order to avoid the confusion that words like corner or side might create. Cross-section is the face formed when a three-dimensional object is sliced by a plane. It can also be thought of as the intersection of a plane and a solid. So first thing we want to do is capture some vocabulary that we were given in this passage. A face, when we talk about three-dimensional objects, a face is a plane shape. It's a two-dimensional shape that makes up a side of that three-dimensional solid. All of our polygons are fair game when it comes to faces, and circles as well can be faces. So a face is that two-dimensional side of a three-dimensional object. Now, where two faces come together, that is an edge. If we think about, I've got a face that's up here, and then I've got a face that's up here. This is a plane, and this is a plane. And when two planes intersect, they actually intersect at a line or a segment. And so the edge is what we refer to as where those two planes come together, that segment where the two faces connect. And so that's where we get an edge from. A vertex, as opposed to an edge. A vertex is actually where three planes come together, three faces. So this top face, this front face, and this side face over here that we can't see, where they come together, they intersect not at a segment, but at one exact point. So vertex and edge provides us with a much more specific wording than corner. That way we don't have those kind of confusions that the English language provides when we have those types of terms. So a vertex is a single point where the three planes come together, and an edge is that segment where two planes come together. And a cross-section, as the paper mentioned, is where a plane intersects a three-dimensional object. Some people like to think of cross-sections as where you cut a three-dimensional object. In fact, in the activity, it was talking about that the boys had cut their clay cube with a piece of dental floss. And so they're actually left with a cross-section that they could look at. Now, draw and describe the cross-section formed when Jamal sliced his cube. So Jamal had taken off the vertex. He had interpreted corner to be vertex, and so he cut the vertex off. And so he kind of ended up with this cross-section right here. I've got a corner, and a corner. So three corners makes for a triangle. So he ended up with a triangle. Now when Jabari sliced his cube, he took off that whole edge on this side, right? So he took off this whole part. I've got a corner, and a corner. So if I end up with four corners to that cross section, it looks like I end up with a rectangle. Experiment with various ways of examining the cross sections of different three-dimensional shapes. In the activity, it mentioned using a jar with water. For our purposes, we're actually going to jump onto GeoGebra. This is a fantastic website that gives us a chance to play with some of our three-dimensional shapes. So if I had a jar, a cylindrical jar, so a cylinder, and it was full of water, and I wanted to, we could fill it to different heights, and I can play with this and see, right now my cross section is a circle. But it does let me do things like spin it. And when I spin it, it's still a circle. It lets me tilt it. And what we see happen is as we tilt it, our circle isn't as circular anymore. It becomes a little more elliptical, gets a little longer. If you were to tilt it so that, it reached the top or the bottom of the glass, it would end up getting a flat edge there because it's right there at the bottom or the top of the glass. So you can play around on these websites at GeoGebra, sections of 3D shapes, and you can check and see what are some of the different shapes that you can get from a cylinder. Now, try to imagine a cubical jar partially filled with colored water and tilted in various ways. Which of the following cross sections can be formed by the surface of the water and which are impossible? So as we're going through, you have a list of polygons, two-dimensional shapes on your paper, and you can use this simulation to help you figure out which ones of those are possible. I definitely see a rectangle, and I see a square. And then if again, you can move it up and down, you can turn it, and you can tilt it. So it lets us do all of these things, and we can play around with what's it going to look like. Oh, now that got interesting. So you can play around with these and figure out which ones will work. One of the big things that you want to get out of this investigation is the fact that the shape of a cross section is dictated by where the plane intersects the faces.